So good morning, everybody, and thank you for joining us today. I want to make a couple of introductions and welcome all of you to this design training. My name is Tim Gustafson, and I am a senior planner with a company called Epstein. We are based out of Chicago, and I have a background in bicycle pedestrian facility design planning. I work on long-range plans. I work on phase one, phase two engineering. So kind of all over the place with regard to it, but I have a lot of interest and a passion for bicycle pedestrian design. And I'm actually one of the sub-consultants on the team for the Decatur Bike Plan, which is actually the reason we're doing this today. So I'd like to introduce the project manager for the project, Cheryl Sharp, who's also on webcam this morning. Good morning, Cheryl.
Hi, thanks, Tim. As Tim mentioned, I'm Cheryl Sharp. I'm with Lockmuller Group, and I am the project manager for the Decatur Bike Plan. We've been going for several months now, probably about 4 or 5 months, and we're about the halfway point here. And as part of this project, we really wanted to introduce the types of bike facilities that you might encounter, that you might see in this bike plan, and we just want to make sure everybody was coming from a baseline understanding. And so Tim is a NACDO certified bicycle design trainer, and so we took this opportunity to do a lunch and learn. So I did want to mention that both ACEC Illinois as well as APA, if you are an engineer or planner, you can get PDHs for this. And so we have information on how to do that, or we'll present later as to how to do that after. So thank you so much, and back to you, Tim.
All right, well, thank you. We've also got Katie Shackelford from Lockmuller Group who's joining us. Katie's going to kind of co-assist in monitoring the chat for any kind of Q&A along with Cheryl. And then our client is the city of Decatur. And with us this morning is Greg Crow from the city of Decatur. Good morning, Greg.
Good morning.
So we have everybody who's joined here, and we've got everybody who has recently joined. For those of you who have not done so just yet, I'm going to ask for just a couple more icebreaker opportunities. The first is if you can find your reactions button. It's either located at the top or the bottom of your screen. Go ahead and press that and select the thumbs up emoticon to prove that you can find that. Feel free to put that up on your screen right now. Looks like we got everybody. Excellent. And then if you haven't done so, what I'd like to do as an introduction and also a record of who's joining us today is go ahead and put your name and your title in the chat and send that to us. I'll be saving a transcript of the chat so that if there's any conversations, hyperlinks, questions, or answers that you would like to see, you'll have access to that as well. And it looks like we've got most of the people who have done that. Okay, we've got 19 people on the line with us. What I'm going to do at this point is we're recording today's webinar so that everyone will have access to it and you can watch it on demand at a later time. Or if there's someone that you work with or that you know that wanted to be here today and could not, we'll make this available both through ACEC and the American Planning Association. So we should have all the bases covered. Before I share my screen, is there anybody that has a question on housekeeping or operations or the way we're going to conduct today? Go ahead and put that in the chat. As we mentioned at the top of the call, we wanted to make sure that this is a conversational presentation today. So we have about 90 minutes of material, but we also anticipate a good, robust discussion. So Q&A, by all means, put something in the chat. Cheryl will let me know. The minute I start to share my screen, it becomes a little bit tougher to see things that pop up in the chat or in the waiting room. So I'll rely on Cheryl to kind of grab my attention when I have some time between breaths. So for those of you who have joined, the reason we're doing this today is the city of Decatur is working on its bicycle plan. And one of the things that we felt was a great opportunity is when you go through the process of bicycle facility planning, the question always comes up is, well, what does this look like? How does it work? And how would you make that fit into your network? And so we always feel like it's a great opportunity to go through the design process so that people get a sense of exactly why we're recommending what we're recommending, where will it fit, and what are we calling it? So this is kind of how we wanted to approach the project. And this is a great opportunity just before the city receives a draft network of recommendations to go through what are these called, what is a shared vocabulary that we all have. And I'll be going through that this morning. So join me, I'm looking forward to this. And I wanted to welcome everybody who's joined us, whether you're curious or you'll be responsible for implementing some of this network in the future. But here's our agenda for this morning. So I'm going to introduce the framework just so that we have, I'm going to admit one more person to the waiting room. We're going to introduce the framework for understanding. as well as go through the various types of facilities that you see here, which we've kind of grouped based on how the Federal Highway Administration likes to think of them, either as shared roadway environments, visually separated facilities, physically separated facilities, and then a module that focuses specifically on intersections and crossings. So we will have opportunities to do all of that, and I'll go into definitions as to what these mean and what this entails. So this next thing that I wanted to introduce is actually kind of an overwhelming diagram, but it's meant to share kind of a simple concept. Is usually when we get into bike facility design, people say, well, where do I start? Like, what do all these guides mean? Why are there so many of them? And so I kind of want to start your understanding at the very top of the image here. And you can see that the Federal Highway Administration, over the course of kind of 3 to 5 years, issued some technical memoranda and some guidance that states there's been a lot of design flexibility that's been coming out and innovation on how we accommodate bicyclists into our transportation network. And they recommended that people look to these guides for reference. They did this once in 2010, and then they did it again in 2013, where they doubled down and said, not only do we recommend that you use these, but we want you specifically to look at federal highway publications, AASHTO publications, and NACTO publications. And I just gave you 3 acronyms, and not everybody may know what these are. So the AASHTO stands for the American Association of State Highway and Transportation Officials. They were responsible for putting out one of the earlier bike guides. You can see kind of a modernized version of the 4th edition, released in 2012 on the far left of your screen. The National Association of City Transportation Officials, these are the very stylized blue, green, orange, and turquoise urban bikeway design guide, stormwater guide, transit guide, and things of that nature. They've been doing a lot of work in that. Then on the far right of your screen, you actually have publications that come from FHWA themselves, where they said, not only do we recommend that you look to these guides for guidance, we're also going to put out our own. So if we have a very conservative Department of Transportation that says we only look at what IDOT says or what FHWA says, they basically said, okay, we'll just release our own guide. And then down at the bottom, and this is the relationship where everything comes from, is you can see the MUTCD, also known as the Manual and Uniform Traffic Control Devices, and then 2 IDOT publications, Bureau of Design and Environment on the left and the Bureau of Local Roads and Streets on the right. These 2 guides are basically the Bibles that we look to for roadway design in Illinois. On the left, BDE is for roadways under IDOT's jurisdiction, interstate highways, US highways, things of that nature. And then Local Roads and Streets is if you are working on a project that's on your jurisdiction, but you're using federal money, there's a process that we want you to follow. So all of these guides kind of play together. But what I would say is, as a general rule, what I like to do is I always start with IDOT. I always start with IDOT, FHWA. And then when you get to a certain portion of the guide where you've got some flexibility, or it actually refers you specifically to look to AASHTO, which Local Roads and BDE actually do, then you know you're allowed to go there because you get more guidance on visual appearance, different examples, or different variations on a theme. So I want you to feel that after today's presentation, you kind of know which guides are out there and how they're all relating to one another. Now I'd like to move on to some IDOT specific policy, which gets you a little bit deeper into the guidance to talk about where do we even start when it comes to selecting a facility. So for those of you who have cracked open these manuals, and I hope many of you at least are curious, I use these all the time. I'm opening them probably 3 to 5 times a week. Is you'll see that the location of the facility guidance is in 2 different locations depending on which guide you're using. So if you're looking in the BDE manual, you'll find this in chapter 17. And if you're looking in Local Roads and Streets, you'll find it in chapter 42. Now the image on the right is figure 17.2a from the BDE, which is a bicycle facility selection table. And this breaks down information based on the average daily traffic or number of cars per day on a roadway, and then what your posted speed happens to be. So you can see a whole bunch of different posted speeds here. And given that ADT and that posted speed, here are the facility types that IDOT recommends you should consider and how wide they should be in order to be effective. So you can see things like a paved shoulder, a wide outside lane, a bike lane with or without a buffer, and then separated facilities, which again, we'll get into here in a little bit. But this gives you at least a good first glance of saying, well, what facility is even appropriate based on the roadway condition? And this is specifically relating to on-street, except when you get into that separated facility. And then you might be getting into situations like a side path or a shared use path, which is something that's in the right of way, but it's off the roadway. And then a couple of other bullets that I have here on the screen are really helpful because they relate to maintenance and jurisdiction as well as funding. And this comes in handy because a lot of you probably will experience a project or a condition whereby you want a bicycle facility, but then you have to enter into a maintenance agreement based on who's going to pay for it. And this typically is related to the fact that it's just easier to maintain things that are all within the existing roadway envelope. The minute you get off of the roadway and you're onto another facility that's separated by a grass buffer or a barrier, it can't be maintained the same way and is usually not maintained by the same agency. So if you're thinking about your network and you want to be strategic about making sure that it can all be maintained or swept or plowed at once, that's where you start to think about the benefits of putting something on the street versus off street, but within the right of way. So this stuff I'll come back to a couple of times in the presentation, but you'll see there's even guidance as to why the local roads manual says sidewalks are not generally good for bicycling except in certain conditions. And they also have another chapter on maintenance. So some of the principles I want to introduce at the front end is just to make sure that we're all approaching this from the same standpoint. So the main principles we always say is, first of all, the facility's got to be rideable. You know, it's got to be in a decent enough condition that you would even feel comfortably riding on the surface, even if there were nobody else around there. And if the roadway's in condition good enough for an on-street bicycle facility, then you want to do things like making it inviting and comfortable, make roadway users visible to each other. So this is why we use signs, pavement markings, and geometry to make sure that it's intentional, inviting, and that people know what to expect of one another based on whatever mode they're using. And then fourth, designing for all ages and abilities is super important. We know that we won't always get a network where everybody who's under the age of 12 or people with families and small children would feel comfortable riding. But if you think about your network, make sure that you do incorporate those facilities into your network and you try and make them as connected as possible so people truly feel like bicycling is integrated into the transportation network. And the final principle is, in order to do that, it's really important to understand the context in which you are operating. So context is a very important consideration. And the reason context is an important consideration is because different bicyclists, different roadway users approach the network differently based on how confident they are, how enthused they are, and what their age and familiarity with the roadway happens to be. So one way to actually describe this is through the process of, it's known as level of traffic stress. So for those of you who may work in the engineering world, you may have heard of level of service, which is how we rate roadways and intersections based on how they perform from a delay and capacity standpoint. Level of traffic stress is a different mechanism that actually rates the roadway by the perspective of the bicyclist based on how comfortable they may be. And this is based on a couple of factors, as you can see here in the infographic, and I do apologize, it's a little bit blurry on my screen, is level of traffic stress is a function of the number of roadway lanes, the speed at which traffic is moving, the volume and type of traffic. So if you have more trucks, for example, you're going to have a more stressful situation. And then how much space is given to the bicyclist? Is it exclusive? How wide is it? And how much separation does that bicyclist have from everybody else in the roadway? These factors then can be used to calculate and estimate a level of traffic stress that rates roadways on the rate of 1 to 4. Level of traffic stress 1 is our lowest stress. Think of these as like a cul-de-sac in a very quiet neighborhood, a trail that's nice and easy for everyone to ride on, and even some protected bicycle facilities where you yourself might even feel comfortable going on a bicycle ride with your family. Level of traffic stress 2s and 3s. This is where we might see like a buffered bike lane or a bike lane on a calm street. And then level of traffic stress 4 are really stressful roadways that either have no facility, high speeds, narrow lanes where there's no room exclusively for bicyclists. And these level of traffic stress numbers also track typically with what kind of user group might actually feel comfortable using these. So in this condition, you think of the population as one of 4 groups. 7% of the population, when surveyed, identified as what we would describe as strong and fearless. These are types of people who are road warriors. They can claim any lane. They don't mind being in a downtown environment without a bike lane. This is a pretty small group of the population. A slightly larger group of the population are described as enthused and confident. This is probably where I put myself. I feel comfortable claiming the lane in most conditions, but I really do prefer a bike lane or a separated bike lane or things of that nature. But this isn't really grabbing that many more people and making them feel excited about getting out on streets and bicycling. So this next group is a really large group of the population. They're what we describe as interested but concerned. They may own a bike, they may feel comfortable bicycling on a trail, but they're not comfortable with the idea of biking to the trailhead. They still want to put their bike in the back of the car, drive there, get in the parking lot and get out there because they just don't feel comfortable on our streets the way they're designed today. And then last but certainly not least, there's about a third of the population that will not bike for many reasons. Either they cannot, or they will not, or they just don't like the idea. And our networks need to be designed with them in mind as well, because we're not creating a situation that's supposed to put others at risk. We want these networks to work better for everybody. So predictability, visibility, this helps to avoid conflicts between people walking, driving, and bicycling. And if your facility is designed well for one user group, it should work better for all user groups. So we've had a few people join us from the waiting room. Good morning to everybody who did just join. For those of you who joined within the last 5 to 10 minutes, one of the things that we've requested is if you could put your name and your position in the chat. We're going to have that as a record and also as a means of putting people in touch with one another. So go ahead and drop that into the chat box if you've just joined us recently. We'll also be using that space for Q&A. So if you have a question at any point during the presentation, feel free to drop it in there and we'll be able to take a break and enter into discussion. Also, for those of you joining, this is a traditional Zoom meeting style format. So you have the ability to mute and unmute yourself as well as come onto camera. When we enter into Q&A, I am more than encouraging people to join and participate in the camera-based discussion. This just kind of facilitates that conversation that we're hoping to have, and I very much look forward to that. So if anybody's joined recently, please put your name and title in the chat and we'll keep on going. All right. So some bicycle principles, I think many of you might be familiar with this, and this I just like to put in here so that you understand why we design things the way we do. And the width of a bike lane is based on how much space a bicyclist needs to operate. So this comes from the AASHTO guide, the image you see here on the right. You generally need a minimum of 4 feet in which to operate a bicycle. And because we know that we wobble a little bit, we actually prefer 5. And then we've even gone so far as to widen to 6. 6 is actually what we now use as a standard without buffers in the city of Chicago, in the city of Evanston, and a couple of other locations where we've done some projects. And you may find that adding space for the bicyclist is preferred over wider travel lanes. So more often than not, I would always tell people that if you have additional pavement width and you've already got travel lanes that are 10 or 11 feet wide, any additional space, I would want you to give that to the bicyclist or to a buffer between users. And you'll see in a couple of slides from here why that might be helpful. And you'll find that you may need additional separation for various situations. So let's say you've got on-street parking and doors are opening and closing a lot. You might want additional width or a buffer to make sure that you've mitigated conflicts in those environments. Or let's say you've got a road that's got buses and trucks traveling on it. Maybe you need an 11-foot lane and a 2-foot buffer so that the width of that mirror doesn't hang over into anyone's travel lane. And as I mentioned earlier, context matters. So when speeds and volumes go up, you will find that you want to separate different users traveling at those different speeds from one another. So when you have low speeds and low volumes here on the left side, you can do shared spaces. You'll like the idea of shared roadways because you're not spending more money than you have to. You're getting the facility that you need for the user groups you're trying to encourage, and you're not having to widen a roadway that doesn't need it. When you have a little bit higher speeds or volumes, it actually makes sense to dedicate some exclusive space. So that's where you start to see bike lanes or buffers entered into the conversation, because maybe just a little bit of visual separation is really all you need. And then the roadway just works better for everybody. And then obviously when speeds and volumes are higher, or when you're alongside of a highway, for example, you really do need that physical separation. And that's when you introduce a curb or a vertical element to physically separate users from one another. So does anybody have any questions on what those 3 groups are before I go on to this? So we've got shared roadway spaces, visually separated spaces, and physically separated spaces. And as you'll see at the bottom of the screen, you can tell which section we're in based on which element is highlighted. Okay, seeing no Q&A, I'm going to move on to our first group is shared roadway environments. So we have 4 that we're going to get into, and I'm going to define each of these for you, and you may be familiar with most of them already. The first is a signed bike route. This is probably your most basic roadway. As we generally say, and I used to have a slide on this, but it's become a lot more commonly accepted, any roadway, unless we have specifically prohibited bicyclists from entering upon them, like an interstate, for example, legally can accommodate bicyclists. But we all know context matters, and if we want people to feel comfortable and we want them to be visible, we need to do things to make that happen. So one of the first low-level things that you can do is by identifying the bike route. And there's a couple of different ways to do this. And we generally say that these work well on roads that are at or below 25 miles an hour with average daily traffic of 1,000 vehicles or less. I would even go so far as to say you could probably get away with it on roads that are 2,500 vehicles or less, depending on the speed at which they're traveling. And what this does is this actually formalizes the presence of bicyclists in the roadway, primarily because you want them to know what's the best way to get to a destination using these low stress, low speed, low volume roads. So you've seen a couple of roadway signs on the right. We have warning signs, generally shown in yellow. We have regulatory signs, which are usually white, red, or black, and then guide signs, which are the green and white. So if you've ever kind of opened up the METCD or you've been driving around, you wonder why these signs are the colors they are. This is the general vocabulary that we use. And the thing that route signage can do is this helps give you identified where the destinations are, how to get to a trailhead. And this goes a long way to making sure that people understand that this is part of the network, even if we haven't necessarily designated a bicycle facility. One of the things I touch on here is the optional use of the bikes may use full lane sign. Comes in handy if you need to make sure that motorists should be expecting a bicyclist where there's not enough room to go around them. So you really want to make that clear. However, signed bike routes are not super comfortable for everybody. You wouldn't necessarily feel comfortable going on a family bike ride if all you had was a shared roadway, for example. So the next level up from that is by installing just a little bit more guidance on the roadway, known as the marked shared lane. Some of you also may know that this is called the sharrow. And what this is intended to do is show the intended alignment or placement of the bicyclist on the roadway. This is a visual reminder to everybody that this is still a shared space. And shared marked lanes are different than bike lanes, and you don't want to necessarily confuse the symbols for one versus the other. So a shared lane is truly a shared environment, where a bike lane symbol is used for exclusive bicycle space. And as you can see here, this is roughly the size of the template if you place it on the roadway. Please don't change the signs of your sharrows. You really want them to be uniform, which is where the U comes from in METCD. So here's some additional guidance on where that gets placed. Generally, you place that shared lane marking 4 feet from the face of curb on a roadway where there is no on-street parking, or 11 feet from face of curb on roads where there is. And AASHTO and BDE and local roads actually send you to AASHTO for guidance occasionally. Here's a section where AASHTO even says on some streets, it's actually recommended to place the sharrow in the middle of the lane, especially if you're sending them through a very tight section, a short area with on-street parking. You want to get that bicyclist out of the door zone and claiming the roadway for that stretch that they need to. And I've even been working on a project where we've got some roadways where we can't do it from 4 feet from face of curb or edge of pavement. And IDOT said actually placement in the center is probably recommended because they're going to be more visible. So here's a condition where sometimes placing in the center of the lane is not only logical, but it's actually recommended by AASHTO. Now to the next level up from that is known as the bike boulevard. And the bike boulevard isn't necessarily one specific treatment, but it's rather a connection of treatments. And the bike boulevard basically takes the concept of a signed route and elevates it by pairing it with traffic calming and pavement markings to truly stitch together a network that is low stress, gets you to your destinations, and provides that added comfort and visibility that we really want to encourage on our bicycle networks. You can see here that we've got a couple of different things in the image. We've got some pavement markings on the roadway. We can name our bike boulevard by putting a name to it and giving some direction. And we can even incorporate some regulatory signage to close off certain stretches of a network to make sure that bicyclists may be able to continue through along with pedestrians, but doesn't necessarily turn it into a raceway for motors. So as I mentioned, this is kind of a couple of treatments, but it's intended to be a roadway that prioritizes bicycle traffic. So it does so by using traffic calming techniques to keep motor speeds and volumes below a certain threshold. Generally, we like this to be below 3,000 cars a day. and at or below 25 miles per hour. If you can get it even lower, it's preferred. And these are great because they often can be built alongside or within a reasonable distance of an otherwise direct but very stressful and busy route. So this helps you maintain your connectivity without having to go to bat or have a huge fight over a roadway that's already very full, very fast, very congested, and you don't necessarily feel comfortable introducing bicyclists into that mix.
Hey, Tim.
And yes.
Do you have recommended traffic calming measures that might be better than some? Or I guess, to say when you're designing these, for instance, a lot of times people for neighborhood traffic calming, they'll use like speed tables. But for like, say, a bicyclist, how would you modify that to be as bike friendly as possible in the implementation?
That's a great question. And actually it has come up a lot. And we had a recent project where we actually took the toolbox to the community and said, here's what all of these things do. Which ones do you like? Which ones don't you like and why? And what we found is generally we find that pavement markings are pretty readily accepted. People kind of get that they're helpful. Signage is really helpful. There are some traffic calming techniques that I think are more popular than others. Miniature traffic circles, which are literally only like 11 to 18 feet in diameter in the intersection at two intersecting residential streets. Those are a little bit more accepted and they're quite popular here in Chicago because they don't impose any kind of flow or speed restrictions other than making you shift laterally to go through an intersection. So it slows you down a little bit, but it doesn't damage your car, for example, unless you smack right into the thing. What I will say is people generally don't like speed humps and tables. They complain that garbage trucks don't like them, ambulances don't like them, motorists that want to go above 25 miles an hour don't like them because they're really effective, but they're also kind of hard to swallow. So that's a situation where if you truly feel that you need to reduce speeds, there's a newer design. It's known as a sinusoidal hump, where if you're going over it at the speed that you should be, bicyclists can do it, motorists can do it, and it doesn't actually work against you. But if you go above a certain speed, it's kind of one of those auto punishment type situations where you really brought it on yourself. But generally, I would say vertical deflection is less popular than horizontal deflection, to use the more engineering approach to the concept. So we have found that generally, if it's a new one or it's novel to that particular client or city, pavement markings and signage are what you start with. And then if you want to impose some additional restrictions after you've tested it out, then you can start to introduce those harder ones. And generally, I would say that miniature traffic circles are kind of one of the first things that we offer. And then every now and then we'll do a curb bump out to bring the roadway down in width so that we reduce the width of a pedestrian crossing. Bicyclists are still able to claim the entire lane, so they don't necessarily need to move over to the curb. And that tends to work well and is better received. So that's a really good question. There definitely are treatments that are more popular than others. This presentation doesn't go into detail on what that entire toolbox entails, but the design guidelines section of the bike plan will contain that information so that people can see kind of the pros and cons of each. And that's actually a really good segue to what I have here on the screen. Is NACTO actually goes into more detail as to why we want speeds and volumes below certain thresholds. And as you can see here, when speeds increase above the 20 mile per hour threshold, you'll see that there's an increase in how many cars or the number of cars or the speed at which cars are passing a bicyclist. And if there's an increase in that passing, the number of times a motorist overtakes you or the speed at which they do so kind of contributes to that stress level. So again, stress levels start to go back up above these thresholds, and you can see that there's an increase in the number of passing events or the speed at which that passing occurs based on that increase in posted speed or ADT. So like I said, NACTO's website has a great module on bike boulevards specifically and goes into a lot of the data behind why we want to recommend certain speeds and treatments and what the benefits can be. And generally, as Cheryl kind of alluded to, there's a couple of different things that you can do in a bike boulevard. You can either regulate speed, you can regulate volume, or you can do things that actually kind of do both. So here's a couple of examples. Sometimes just reducing lane widths will help calm traffic. And again, if you calm traffic and reduce speeds where it's shared, that might actually work in your favor rather than giving space to bicyclists and making the roadway wider. And sometimes it's not feasible to widen your roadway. So as I mentioned before, a speed hump or table, a miniature traffic circle, a curb extension, maybe introducing an island into the roadway so that cars split around both sides, slows everybody down. Those are some speed treatments that you can use. Let's say you want to reduce the volume of traffic through a certain area. You can reconfigure the roadway lanes, for example. Sometimes it's known as a road diet, where you take 4 lanes, you restripe, and now you have 3, room for a bike lane. It's not a bike boulevard treatment per se, but it's one type of treatment. Adding or removing on-street parking, that's another option. I live on a street where 2 vehicles cannot comfortably pass one another because there's on-street parking on both sides. City of Chicago prefers it that way. Otherwise, all of these roadways would have speeding problems. And then sometimes changing your signal timing so that, if you're speeding, you're going to meet every red light and you're just going to find out that that's just not a desirable street to drive on, for example. And sometimes putting in a cul-de-sac or diverter where bicyclists and pedestrians can go through, but cars cannot. That's a pretty typical and actually an increasingly popular approach, especially if you're closing off a grid that's got more than enough alternatives. So here's an example of a curb bump out. This is actually a retrofit. So the existing curb stayed put. There's a flow through curb by narrowing the roadway, adding some landscaping. This does a great job of reducing the roadway width. And it's still bike boulevard friendly because the crosswalks are still where they're supposed to be. Speeds are reduced. You add a little bit of green space, you reduce a little bit of stormwater runoff. Sometimes these are imposed in neighborhoods where flooding was more of a concern, and it just also happened to have a bike boulevard benefit. So this is a situation in Chicago, but we've also worked in a city in Wisconsin where they had a stormwater utility ordinance and they needed to reduce stormwater. They decided to put their bike boulevard network into that concept. And then it was the city engineer working on the stormwater side as well as on the bike plan side, kind of getting these projects to work together. So that was the introduction to the bike boulevard. Now I want to move on to a topic that's actually a little bit newer. And it's something that is relatively recent, has only been added since the Federal Highway Administration released its Small Town and Rural Multimodal Networks Guide, and has recently been added as an experimental treatment per the MUTCD. And it's known as the advisory bike lane, the advisory shoulder, or the dash bike lane. And I will admit that the reason it's still experimental is because there's still not even consensus on what we're supposed to call it based on how it's being used. But generally, this is a situation where you don't have enough room on the roadway for an exclusive bike lane, or you still need a shoulder because you're dealing with a rural roadway and you have breakdowns and other curbside uses that require the need for a shoulder. And you can't exclusively sign it as a bike lane if you also need it to be a shoulder. So in this situation, AASHTO recommends that if you have at least a 14 wide foot lane, but you don't have enough room for other things, you're going to need to impose what's known as an advisory bike lane or advisory shoulder. And this was popularized during the vehicular cyclist movement because we wanted there to be somewhere on the roadway for bicyclists to travel, but we couldn't designate it as exclusive. And so this is still kind of evolving treatment where you need regulatory and warning signage to let people know what's going on. But let me move to the next slides because this explains it just a little bit more. So you've got a 2-way travel lane, the center of which may actually not be wide enough for 2-way traffic as currently signed. But this is why the shoulder or the bike lane is dashed, because when you're passing a bicyclist, you'll go around them using the center travel lane. If you're passing an approaching motorist and there's no bike lane present, both of you move over into the shoulder because there's enough effective width for you to pass. It requires that you do not strike the center line, and you only would want to pursue this in a low speed, low volume environment where you really want to kind of narrow the lanes, give some semi-exclusive space at the shoulder for bicycling, and then give everybody enough regulatory signage so they understand what's expected of them. It's a permissive broken lane line. This image shows contrasting pavement. We don't see that as much, but there are some examples I'm going to show on the next slide that do. Because they have roadways where they want to provide that guidance, they want to provide that facility, but there's not enough room to make that a solid lane line because there's just not enough effective width. So here's a couple of examples. Upper right, we see Bloomington, Indiana. They decided to do this on a low volume roadway because they needed to do some traffic calming and they wanted to provide space for all these users. And this example still included a sidewalk. So you've got your advisory shoulder, you've got your sidewalk, and you can even see that some people are walking in that advisory shoulder. Not how it was intended, but not the end of the world because it's a very low speed environment. Contrast that below with the city of Chicago that started doing 9.5 foot or 9 foot travel lanes, next to which they would place an advisory bike lane. And this is done in the presence of on-street parking and transit and two-way traffic, where they really knew that they needed to provide better guidance above and beyond what a Shero could do, but they needed to do so with very constrained widths. So they've got 9 foot travel lanes and then a 5 foot bike lane. So that's that 14 foot envelope that we were talking about. We've just split it up differently than we're used to doing so. And then in Minnesota, this example shows the presence of on-street parking. And then I'm going to guess, and I haven't actually visited this one, later on down the road when the on-street parking goes away, there's enough room for a bike lane, but not through this stretch. And they didn't want to drop the bike lane and go to a Shero. They wanted to give a little bit better guidance. So the bicyclist coming towards you in the foreground, she's moved back over into the bike lane or the parking lane, because that's where she feels more comfortable. And the facility communicates that to everybody using the roadway. So as I mentioned, this is an experimental treatment. I strongly recommend using this two-way traffic warning sign so people know that this is not just a one-lane road, but that you'll expect users in both directions. So that's the end of the shared lane or shared roadway environments. Are there any questions, Cheryl, in the chat that I missed?
At this time, no.
Okay, so now let's move on to visual separation. This is a situation where you do have the space and you do want to visually separate users to give them a little bit more visibility with one another, a little bit more comfort, and a little bit more safety. And there's 4 that fall into this category. There's the wide shoulder, your typical bike lane, buffered bike lane, and the contraflow bike lane. So wide paved shoulders, we're probably very familiar with these, but I want to give you a little bit of guidance on how they're designed so that you can kind of see how they operate. Some roadways still need to have shoulders, but just because they're shoulders doesn't mean that bicyclists can't use them. And as I said in the advisory shoulder section, if they still need to operate as shoulders, that's why you won't see a bike lane sign added to them. Oftentimes we'll have advocates come to us and say, can you at least just put up a bike lane sign? And I say, unfortunately, then it's no longer a shoulder. So then you need additional facilities, but that doesn't mean you can't still use them. So this is a situation where if you're going to do a shoulder and you want it to be suitable for bicycling, aim for a 2 to 4% cross slope. BDE allows you to have a cross slope up to 6%, but that makes it a little bit harder to stay upright on a bike. So if you know it's going to be used as a bicycling facility and you're paving it as a shoulder, aim for that lower slope rather than the upper limit that they allow. And these are helpful on suburban and rural roads when you've got to connect 2 parts of town, or you've got an unincorporated section, or you don't want to necessarily put a side path in and enter into a maintenance agreement because that just creates a whole host of problems. Sometimes a wider shoulder can do all of that and do that a little bit better. And a couple of the benefits is this also just makes your pavement last longer. You don't have heavy vehicles rumbling at the edge of an uncontained edge of pavement. You don't have a curb for this situation. And as I consulted in kind of the northern climates, this is where the snow gets piled in the winter. And unfortunately, that does impede the bike lane unless you clear it all the way off. But it also assists with delivering mail. It increases the turning radius at intersections. So paved shoulders have a lot of benefits, not just for bicycling, but if you're gonna use them for bicycling, there's a couple of considerations, like the shoulder gets plowed along, or should get plowed and swept along with the roadway. And this can help to make sure that it stays clear for bicycling throughout the year. Now, there's another thing that I usually like to touch on. If you're dealing with these rural roadways, there's a chance that you may have design guidelines that require that you use rumble strips, or there's a desire to do so. But what I like to say is rumble strips by themselves are not a bike design element, but if they are on your roadway and you are adding shoulders and you think you need rumble strips, then there is guidance for how many times you want to put a brake in those so that a bicyclist can enter and exit as needed to make evasive maneuvers, go around roadkill, things of that nature. So they recommend that you maintain a clear space of 4 feet beyond the rumble strip and the edge of pavement, so it's still rideable. And then you provide a gap every 40 to 60 feet. And this image kind of shows you where that would go so that you could enter into and out of the bike lane. The rumble strips also do a really good job of making sure that motorists don't encroach on that comfort space because it makes things unpleasant for them. And you get a visual cue a couple hundred feet back that someone's doing that. So then we'll upgrade to the next one, conventional bike lane. This one I think is pretty well understood. It's dedicated space for exclusive use by bicycling. and it needs to be at least 4 feet wide to the edge of pavement or 5 feet to the face of curb. NACTO recommends 6. Again, 6 is just a lot easier. And as we're finding when reallocating roadway space, if you're converting one or more travel lanes, you end up like to work in pretty even numbers. So let's say you've got a 10-foot travel lane, take that out and you've got a 4-foot buffer and a 6-foot bike lane. Your lane lines didn't move. You just reassigned kind of an added one. You're going to need wider widths if you're adjacent to parking that doesn't have a buffer, or if you're on streets with posted speeds above 35 miles per hour. Michigan DOT, especially in the Detroit metro area, 12-foot lanes everywhere, multiple lanes on a given highway. They actually had to do a 6-foot buffer and a 6-foot bike lane because they were replacing 12 feet of space. And here's the typical placement of pavement markings and signage as it relates to it. So again, ideally bike lanes should go on roadways that are between 25 and 35. Below 25, you don't really need exclusive space. Above 35, you kind of need something better. And these work best on roadways between 3 and 10,000 cars per day. The required elements per MUTCD are a 6-inch edge line adjacent to the travel lane, so other moving vehicles. And then you need the bike lane symbol. Optional to add to that is maybe an additional line between the edge of the bike lane and the parking lane, or to the edge of pavement. Generally, if we do on-street parking, we like to stripe it because we want to make that very clear. And then you can add signs to supplement your pavement marking. So the bike lane sign itself, this black and white, not required. Oftentimes you'll see that when it's the first bike lane in town, but they don't necessarily do anything beyond making it very clear that this regulatory guidance is out there and that there's an exclusive bike lane on the roadway. Now, if you have space above and beyond that, I've been talking about buffers a lot. Buffered bike lanes actually do a really good job giving that added comfort, safety, and visibility, because you can add a little bit more space between roadway users or bicyclists and parked cars. So if you have space to add a buffer, you need at least 1.5 feet. Typically, we'll see a 2-foot or a 3-foot buffer. City of Chicago, when we do a 2 or a 3, we start adding the hatches. So it's very clear that it's not a double white or some weird pavement marking. So we do that at a 30, 45 degree angle, space it every 20 feet or so. And we usually say that your spacing of your hatch can typically just kind of match your posted speed. So if you got 20-mile-an-hour posted speeds or 30-mile-an-hour, space them at 20 or 30 feet. And then the question often comes up, maybe even in the planning phase, which side do you put the buffer on? Do you put it on the travel side? Do you put it on the parking side? Sometimes if you have space, you can put it on both. The general guidance, which you can get from NCHRP or just based on this, because we actually measure these widths and passing distances and compliance. And we found the general guidance is put your buffer on whichever side of the bike lane you think the hazard is bigger. So if there's lots of car doors opening and closing, put it on the parking lane side. If you have trucks and buses passing you on the left, put it on the left. And again, if you have the space, putting it on both is ideal. And as I mentioned before, sometimes if you're just reconfiguring a roadway, this helps to organize the space so that you're not creating kind of a no man's land or an extra wide lane that would encourage speeding. So this example in New England, this is actually New Hampshire, they were taking one of the travel lanes and they recognized they had 10 feet. So 4 and 6, 6-foot bike lane, 4-foot buffer. And this allowed the center line and the travel lane line to stay where it was before. They just had 2 lanes instead of 4. This was a really low speed, low volume roadway. They wanted to discourage speeding on the rare events that it was happening. So by adding the bike lanes, they made sure that motorists only had 1 lane to work with, reduce speeds, reduce crashes, and just generally organize that space. I will also say that buffered bike lanes kind of function in a manner of accommodating heavy vehicles without making a 12-foot lane look extra wide for everybody else. And I'll show that to you on the next slide. And as I mentioned before, this buffer just really helps to organize, place people in the center of their lane. And these buffers really help organize everything else that's going on, from mirror overhangs, car doors, things of that nature. So here's a sketch kind of explaining that. So on the left, you've got your conventional bike lane, sidewalk and travel lane, it's 12 feet next to a 6-foot bike lane. That produces just shy of 3 feet of space between the 2 users. In Illinois, we have a 3-foot passing law where you should give a bicyclist 3 feet of space when overtaking in a roadway environment. But I don't know about you, it's not real easy to know if I'm meeting that when I'm passing a bicyclist in a car. Am I at 3 feet? Am I at 2 foot, 2'9"? So if you add a buffer, By reallocating the same exact roadway space, you can ensure that passing distance without everybody having to do math while driving. So here's a situation where you've increased that, but you haven't done anything else to the roadway. This is why I think buffered bike lanes are so beneficial, because they go a long way to increasing comfort and safety without a lot of added cost. So the next item I want to talk about is the contraflow. Contraflow is, it sounds more complicated than it is, but the contraflow bike lane is a great facility solution that can help accommodate what was previously wrong way riding. So if you have a city that has a lot of one-way streets, but bicyclists don't feel comfortable going the long way around, or that long way around happens to be really unpleasant, maybe changing the way that your roadway operates is a better solution after all. If you're going to do this, the required elements are you definitely need to have a double yellow line on your roadway, or in some cases a dashed yellow because you could still cross. And then you have to install signs like the one way except bikes, so it's very clear. And this is from a regulatory perspective so that you can actually enforce these behaviors if you're seeing people do things that you don't want. You'll want to add the bike lane symbol or the word, just like we did on a regular bike lane. And then we're going to want to install traffic control devices like stop signs and yield signs, because now you have people traveling in a direction on that roadway where they weren't previously, so they're going to need all new regulation signs. And then you can add the two-way warning sign, which I actually recommend, especially if you're showing it for the first time in a city, or it's the first time a motorist would be encountering bicyclists traveling in the opposite direction. But at the end of the day, contraflow bike lanes are basically just two-way streets. They're just two-way streets for one user group. So rather than thinking about them as a special treatment, saying, well, we'll do a contraflow bike lane because we need to allow two-way movement for bicycles and keep it one way for cars. And this can be done in the form of a shared lane in the same direction as motorized vehicles and a contraflow just for bikes in the other direction. If you don't have the space to do that, that's an option as well. So now we're starting to mix and match shared lanes with traffic, contraflow lane against traffic. So I know I went through the visual separation pretty quickly. Are there any questions, or Cheryl's, or anything that you wanted me to go into some additional detail on?
I wrote a list of a couple things here, if you don't mind going into.
Absolutely.
So can you elaborate on the importance of accommodating bicyclists at intersections, not just segments? You know, for instance, we talk about accommodating them on the shoulder. What happens when you get to the intersection then? Do they go from the shoulder onto a shared lane? You know, what is the best way to accommodate that? And, you know, and it's great, you know, if you can accommodate people on a bike lane or, you know, buffered bike lane, but it doesn't really lower their level of stress unless you take care of them at the intersection. So can you elaborate on that a little bit?
Yeah, that's a great question. And I've dedicated an entire module to that because
Great.
people always bring that up. So yeah, I like to get people comfortable with like, okay, let me get my mid-block understanding down, and then I'm going to show them what happens at the intersection. Because for far too long, and I still struggle with this on some of our designs, is you run out of space at the intersection and you kind of do like a facility drop, which is like the worst place to strand a bicyclist and subject them to motorists that are now like, where are these people coming from? So when we get into that module, remind me to touch on each of these so that you can remind me about the shoulder, for example. So I'll give that example here because I know it's at the front of everyone's mind. So if you have a paved shoulder and that paved shoulder is approaching a roadway intersection, ideally that shoulder will carry itself around the radius of the intersecting street. And then if you put in a pavement marking showing a crosswalk, it at least gives that visual reminder that there is a crossing taking place at this location. That's one way to do so in rural environments, or in some of those environments, depending on where the shoulder is, you may see a break in the lane line so that it becomes very apparent that there will be a crossing event taking place. So as I mentioned on the slide about paved shoulders, they're not the best solution for comfortable facilities, as you mentioned, but adding pavement markings and signage to alert motorists of the presence of bikes is a great way to give everybody another reminder as you approach an intersection. And each of these other facility types that I've introduced here this morning, we're going to also get into how each of those can be treated as you approach an intersection. Because what we've found in the most recent 5 to 8 years of bike facility design is a lot more advancement on intersection design, not the mid-block. We've got a pretty good vocabulary on mid-block. We're refining things a little bit, but it's really the intersections that needed the most work. So I'm excited to offer that here in a little bit.
And then I have two other questions, and one gets pretty nitty gritty here. Sorry, but curb and gutter, is that in addition to the bike lane width? Do you consider that as part of the bike lane width? You know, how do you deal with curb and gutter?
Yes, so the qualified answer is yes, I consider the face of curb as part of the overall facility width. But generally what we tend to say is you want 4 feet of rideable space to the edge of pavement, 5 feet or more to the face of curb, because it gives you effective width, but it's not a very rideable surface. So in some conditions, when you see your gutter pan and your edge of pavement and they're all kind of part of the same bike lane, if you find that you're asking the bicyclist to ride on the seam between those two, it's going to be a very unpleasant situation. So I generally like to say 4 feet minimum to edge of pavement, just like AASHTO, and 5 feet to face a curb. And then NACTO went so far as to add a foot to the whole mix just so that there's plenty of space to operate. But yeah, generally when you're looking for space for travel lanes, I like to use edge of pavement just like you would for an automobile. But in the case of like parking lanes, for example, City of Chicago uses to the face of curb because when you're coming to park, you're traveling at low speeds. You need all of that width, and it doesn't matter if it's curb or if it's gutter pan or if it's edge of pavement. So generally, if you're talking about moving vehicles, bicyclists or motorists, you want to use that edge of pavement as your general guideline. And then that face of curb is just that added bonus when either you're not moving or you're constrained for space.
Okay. And then the last one you probably hit on later as well, but I was just starting to think about buses. You know, you were showing that really busy street, you know, and just the interaction with buses. Is there a certain level of bus service that is just, you know, you ought to maybe see if there's a parallel route for bicyclists instead of, you know, mixing with the buses, kind of getting into like transit and heavy vehicles. So I don't know if you get into that later in a later module too, but just what are those considerations when you're trying to build out your network or, you know, do some implementation. So that was all I had for now. So
Okay. I do want to speak to that one first because that's actually something that the city of Chicago and the city of Champaign and to a lesser extent, I think other college towns have had to address. So oftentimes we put our bike lanes on our collectors and our arterials because that's where people want to be. Those streets also happen to be our transit routes. And so we're basically introducing a condition where a vulnerable user, be it the bicyclist, is traveling the same lane or adjacent to the same lane where a bus is coming frequently to pick up and drop off people. And that creates a conflict, and we even call it like leapfrog. If you've ever been on a bike in a city that has a transit route that you're parallel to, and you're finding yourself, you know, overtaking the bus and then it overtakes you, and then you overtake the bus and it overtakes you. And that creates a situation that nobody really likes. And so when we have higher volumes of that and working with the transit authority, either in Champaign or Chicago, we kind of had these discussions. There's no hard threshold that I use, but I do know that the Transit Street Design Guide that NACTO has put out that's also free gives some case studies and design guidance for what to do in that situation. And there's treatments that I don't get into today, but there's really great ones out there that show how you can treat a bike lane in the presence of a bus stop, how you can actually create a transit boarding island so that you now separate those users. And then one of the more old school, I would call it, but it's still tried and true and works pretty well, is sometimes putting the bicyclist on the left side of the roadway, what's known as a left side bike lane, sometimes might be the easiest way to do that, provided you have one-way networks and you're able to separate your left turn conflicts, which I'll get into in the intersections module. There's a lot of ways where you can do that. And sometimes bikes and buses don't mix all that well. And so sometimes it's better to put them on other streets, like you say, or put the bikes on the left side because you've got a one-way pair in your downtown and it just works well. We're actually working on some projects where we're moving bikes either to the left side or creating a contraflow to avoid that exact situation. So Transit Street Design Guide and the Urban Bikeway Design Guide has just been posted by Cheryl in the chat. So if any of you are familiar, here's where you can find those. And as you get into those kinds of things, you'll see lots of examples and case studies for how a city figured it out, because there is no standard per se. There's just a lot of really good guidance. So does that sum that up, Cheryl? Or do you have other questions? We
I
may have
think
lost you.
that no, I just couldn't unmute myself. That's all I had for now, and I don't see any other questions in the chat right now.
Okay, sounds good. Thank you. So the next module I want to get to, and this is an area where I think we've seen a lot of advancement in recent years. And it's been exciting because we as a country have started to truly embrace these as being good components of our network, is our physically separated facilities. So this, as I mentioned before, is where your speeds and your volumes are high enough for automobiles and other roadway users that you really want to provide a separate facility where there is something physically between the bicyclist and everybody else. And so these fall into three categories, which are actually kind of variations on two categories, is our separated bike lanes and our shared use paths. And when a shared use path is located within 5 feet of an actual roadway or within the right of way, we give it another name called a side path. That's primarily because there's certain things that you want to do when those side paths meet intersections, which, as I mentioned, we will get to, so you can kind of see how all these interact. So first up is our separated bike lane. And as I mentioned, a separated bike lane on the previous slide, it can be a one-way facility or a two-way facility. So you can see examples up top for one-way facilities, all three of which happen to be in the city of Chicago, but that's not the only place we've seen them installed. And then images on the bottom of the slide are two-way facilities. The first two are in Chicago, and the third is in the city of Evanston, which is just north of Chicago, and is about 1,200 feet away from where I'm standing. So separated bike lanes are near and dear to my heart because I think that they do a really good job of providing that comfort and safety that we're seeking to get from those roadway users who are cautious or interested but concerned, enthused and confident. So this is a situation, as I mentioned, you put a physical element in there that helps separate physically the bicyclist from everything else. This can be done through the use of on-street parking. It can be done through the use of the barrier curb, as you see in some of these examples. It can be done with a mountable curb. You don't necessarily need it to be impenetrable force preventing cars from encroaching upon it, but sometimes just putting in a mountable curb is enough. Sometimes we're starting to see like bumps in the roadway. They're mountable, but they're much lower. You can use a median or planters, and you can even use flexible delineators, but I put an asterisk next to this because the flex posts or these flexible delineators, they're kind of like a glorified buffer as far as I'm concerned. So they do a pretty good job, but I would really recommend if you truly want that comfort, you want to put in something a little bit more robust than that. And a lot of people say, well, where is this in the MUTCD? Most of what we're talking about is kind of after you've done your pavement markings, which are under the purview of the MUTCD, you're actually dealing with curbs and geometry. So it's not something that you would necessarily just go to the MUTCD for, but this is where you go back to the AASHTO guide, the NACTO guide, you go back to the local roads or the BDE manual for IDOT. And there's even a section in here that basically reminds everybody, it's like, it's not a traffic control device. So the MUTCD doesn't really say anything about it. It doesn't say no, but it also doesn't give you the guidance that you're looking for. So that's where I say go to these other facilities. And one of the best ones I think is out there is actually the one that FHWA put together, is the Separated Bike Lane Planning and Design Guide, which is also free online. So you can Google these terms and you should be able to find a PDF without too much issue. And the reason I like this one is because they give you a typical section, or like a typical section plus a plan view extension. And then they show you a photographic example for a city that's done so. So you can see that you can do all sorts of things with your separated bike lane. This one in Cambridge on the left, they've raised the bike lane up and it's almost at the level of sidewalk level. In fact, the only thing they've done here is contrasting pavement. So it's at the sidewalk level, but we've used pavement markings, contrasting pavement colors to truly make it clear, here's where you walk and where you have the stroller, and here's where you can bike. And it's still more comfortable because the bicyclists are separated from the roadway and we've organized the space. So here they show kind of a 3 to 6 inch height differential being that physical separation from the roadway. And then on the right, we've got another example where they took a buffered bike lane and they kind of added to it. So in this situation, they marked a buffer. This looks like a conversion where that used to be a full travel lane. They've marked the buffered bike lane. And then on the outermost edge of that buffer, they put in the flexible delineators and the precast curb stops, which they actually just kind of put in a line. And this is really a good way to do it on the existing roadway, because now you're not having to change your drainage profile. Your inlets can stay where they are as long as your grade didn't change, and you can have water flow through, and you can put breaks in your curbs wherever you think they're needed, and you can still get a high quality facility as part of a resurfacing. Now you're not digging into drainage impacts and moving inlets and stuff like that. So this is something that we've actually seen implemented a lot of places because it is something that can be done within a reasonable amount of time and cost. The Evanston example that I showed you a few slides earlier, that was a project that they felt worked better for that roadway because it wasn't being reconstructed through that stretch. Farther north, it was going to be, but here and here in the Boulder, Colorado example, they were able to do so by adding these curbs and flexible delineators without having to do some additional scope. So that was a great example. I know that a lot of people are concerned about maintenance, and obviously you still have to get a vehicle in here to sweep, which I'll show you in another slide on what your effective width needs to be. But these do a great job of giving you that comfort that you're looking for. Kind of looking at it from above, there's a bunch of things that you want to consider when designing these, because if you're placing your bicyclists and your bike lane back behind on-street parking, you're going to want to make sure that your sight lines are working. So if you follow with me from left to right here on the screen, you'll see kind of things highlighted in orange. FHWA, recommends that you want to keep a clear sight triangle of 15 feet on the approach so that motorists can see bicyclists coming through the bike lane. Even though it's a one-way facility, we make a symmetrical sight triangle just because we want to be able to see in both directions no matter what. Then on the street side, we pull the parking back about 20 feet from the curb, which more often than not, you're doing anyway. So you want to make sure that you maintain that so that you have the visibility for motorists kind of turning onto the side street and being able to see the bike lane before they make that move. And you can do that with pavement markings or with a curb. So as I mentioned here, curb versus pavement marking, it's up to you. Sometimes we do it first in the pavement marking, and then 3 or 4 years later, we come back and actually make it official by adding the curbs. That's a great way to try it out and just see if it's working before you go through the added cost of adding and changing curbs. Then you'll see on the right, which we kind of show everywhere, is you want to identify conflict zones. And this I'll talk about a little bit more in the intersections module, but conflict zones have become kind of the area where green has come about. The use of green pavement marking has become associated commonly with bicycle facilities based on MUTCD and NACTO and the other guidance. So what you'll see is these conflict markings marked with 2-foot bars spaced 4 feet center on center, or 6-foot bars spaced 8 feet center on center. This is actually still something that in working with the city of Chicago, we've adjusted kind of what the optimum pavement marking separation is to still truly communicate it without blowing the budget on the use of a lot of green pavement marking. So this kind of shows you generally where you wanted to think about things in terms of design from a sight triangle, parking restriction, and conflict detection zones. So this is from the FHWA guide that I mentioned. So here's an example, also in the city of Evanston, for those of you kind of looking at this as an example, where we have a protected bike lane. There's on-street parking kind of behind the camera in this shot. And then here's the clear zone that we're marking approaching an intersection. And then we use green to highlight the conflict zone at the intersection. And then this bike lane is actually transitioning back from a behind parked cars back to a traditional bike lane in the back and farther downstream. And that's not impossible. And it's not the end of the world to do so at the transition here. Ideally, it'd be better if you did it mid-block, but this is not terrible from a design standpoint. Speeds are low enough, volumes are low enough, and everyone can see one another. And we've day lit and pulled that parking back so that you can make that transition, because your roadway is not going to be the same width everywhere. And in this condition, they went back to a traditional on-street parking. This also happens to be in the presence of an elementary school. So that's why you see some crossing enhancements and things like that. And this also happens to be a bus stop. So basically everything that you can think coming into the environment is here. On-street parking, transit, bikes, peds, school zone, everything is here. But the city of Evanston still has this in effect, and they're continuing to monitor its performance. So this shows an example of the protected bike lane approaching a conventional bike lane. Now, I've talked about bike lane design from a general standpoint. I want to talk a little bit about the difference between one-way and two-way. So a one-way bike lane does provide that high quality and low stress facility. It does require more space than a conventional bike lane, because obviously now you're adding a buffer. The buffer needs to be wider. It's adjacent to on-street parking, so you pull the parking back so that you can see things a little bit better. But as I mentioned when Cheryl brought this up earlier, the image down on the bottom is actually showing a bike lane on the left side. And the bike lane on the left side is kind of because we're trying to get bicyclists away from a conflict situation. And so I know it's kind of a little bit of a leap to be like, well, why is he talking about left side bike lanes now? And then starts talking about two-way facilities. So as we mentioned before, a protected bike lane takes up more space than a buffered bike lane or even a conventional bike lane, but it really gives us that comfort that we're looking for. But if you put two protected bike lanes next to each other, they share the same buffer, and effectively two one-way protected bike lanes on the same side of the street take up less space than one-way protected bike lanes on opposite sides of the street. So in North America, United States primarily, we're starting to see a lot of two-way bike facilities on a roadway, whether it's one-way or two-way. And Europe's designers were looking at us going, why the heck are you doing that? But more often than not, it was kind of replicating that side path experience that we have on our trail network. And we're trying to find a way to make it work in an urban environment. So we started to see these pop up in a lot of places. This allows you to install an 8 to 12 foot bikeway with a 3-foot buffer. So you could effectively get this into 11 feet of space, although I definitely recommend that 14 to 15. And this allows you to share the buffer. You can protect the buffer through the use of the curb, or as shown on the right, you can use your flexible delineators. And this allows you to mark the bikeway as a 12 foot, maybe a 10 or an 8. And then you can do that 3-foot buffer, and then you use that separation from other moving traffic. This is really kind of something that was born out of necessity. So if we decided we wanted to do two-way protected bike lanes, we needed to figure out how to make them work. So as you can see, this is some additional guidance from the FHWA separated bike lane planning and design guide, showing how far apart do you want to space your flexible delineators, where do you put your pavement markings, and then they go through the variations on this theme as it relates to a one-way roadway here on the left. So we've actually introduced one-way for automobiles, two-way for bikes, but it's a little different than your contraflow because now you've got a two-way street next to a one-way street. So you need to think about the conflicts, which we'll get into a little bit more. And then on the right, you've got a two-way street with another two-way street next to it. We've just separated the user groups. And that is like the Evanston example I showed before. Dearborn is a one-way street in Chicago, but the bike lane is two-way. So we've got a lot of examples now around the country where we're learning like how do these work in each of these environments, because they're very different. So I know I've jumped around a little bit. So this is discussing kind of the two-way bike lane facility and why we're doing them. But I want to get back to one-way facilities to explain an effective width example. So as I mentioned, putting the buffer in and then putting the bike lane in gives you this really high quality facility. Put your flexible delineators or your barriers kind of on the outside edge, 1.5 feet from the traveled way, like all other streetscape elements or curbs. That's where you would want to put it. And when you do this, you make sure that this effective overall width is big enough to plow or sweep, for example. And in the city of Chicago, we definitely need to sweep and plow. So we wanted to make sure these were big enough to be maintained. In the image on the up top, you'll see that we have a bike lane of 7 feet and a 4-foot buffer. We took an 11-foot travel lane and just reorganized it. This allows a general city of Chicago streets and sand truck to get through, sweep it or plow it as needed. Down below, it's a little bit narrower because the city of Chicago does have equipment that can sweep an area about 7.5 feet wide. Champaign was in the same boat where they had campus snow clearance equipment. So these smaller Bobcat styles can get into those facilities and keep them clean or keep them plowed in the winter. So when you're thinking about your protected network, think about what kind of vehicles you're going to be using to plow, and then use that to adjust the lane and buffer widths that you're used to using or allowed to use to meet your needs. And that's why we have guidelines so that you're not just beholden to a single standard and there's no flexibility. So here's a situation where you've got a couple of examples for how to do that. And this can be done whether the facility is one-way or two-way. So that's why I kind of jump around a little bit between the two-way facility, the one-way facility. So I'm going to stop again and see, Cheryl, if you had any questions or if you've collected any questions in the chat.
Tim, this is Katie. I don't I didn't write my question in the chat, but I do have a question. Could we go back a few slides where you showed the bike lane changing from behind parking to in front of parking? Yes. In this situation, this particular situation is right outside my front door, actually. And what we see often is people cutting into that buffer zone to make the right turn so that they get out of traffic. Is there anything that can be done to prevent or protect the bicyclist better? Because it seems to be like it's turned into a right turn lane.
Yeah, that's an excellent question. And that's actually one of the shortcomings of this design. So I like to show things that are not 100% awesome all the time because they're teachable moments. And this is a situation where the exact same thing is happening here is motorists are moving to the right to make a right-hand turn. And actually CTA buses are also moving to the curb in this location. So what I'm going to recommend in my answer to your question doesn't work if you have transit. But if you do have transit and you still want to make this better, move your bus stop to the far side of the intersection and add flexible delineators just in the approach to the intersection to make it very clear that motorists can't move into the buffer zone to make their turn, but can only begin their turn after those flexible delineator posts. So you've made it very clear, kind of slow your speed, slow your turn, and make everybody a little bit more visible. I would even go so far as to say that if you have cut into your buffer like this, use that also as an opportunity to bring the bicyclist back out adjacent to the travel lane. So that's a straight shot across and you're not having any kind of lateral shift at an intersection because you never want to do that on roadway design and you wouldn't want to do that in bike design either. So in this situation, I would do two things to this approach. I would taper the bike lane back toward the travel lane so that you're traveling parallel to traffic across the intersection, move the bus stop to the far side and insert some flexible delineators right at the turn approach to make sure motorists can't turn before you want them to.
Great, thank you.
Okay, good question too, because I think I get into another example in the intersection module showing another area in Chicago where we had motorists cutting off bicyclists all the time. And my colleague at the city had been designing this idea that he'd want to see implemented, and it actually works great. So I'm going to get into that again so you can see another version.
Yeah, and I think I just wanted to hit on 2 points that, Tim already mentioned, but one, with the physically separated facilities, don't let drainage scare you away from using them. There most likely is an engineering solution, so I a lot of times I have heard, and had some clients that are averse to using those because they're just, oh, but what about drainage, and there is a solution. We can work around it, and so don't let that, thought, prevent you from moving forward with that type of, this type of solution. And secondly, just regarding the maintenance, Tim mentioned, I've also heard of, say, somebody sticking a plow on like a little, like a narrower pickup truck, and because those do tend to be a little bit, smaller width as well, so definitely think about the maintenance of these. I mean, because it's a lot of times, the bike lanes are usually against your curb, so that's where the trash tends to end up, whether it's plastic bottles or whatnot. And then all of a sudden a bicyclist is having to leave the bicycle lane or their protected area, just to go around some garbage or whatnot. And so it's really important to think about the maintenance of these lanes, and that is not just installing, it's not just set it and forget it,
Right.
that you have to consider that as you proceed in implementation.
Yeah, that's an excellent point that Cheryl's made. And actually, when it comes to making recommendations for the plan, we want to start with the best facility possible. And if the city learns after adoption that that facility may not be feasible, you know what your next best thing is. And as I mentioned in a lot of these examples, even the city of Chicago and other progressive cities that really push the envelope from a design standpoint, they may start with pavement markings and flex posts and then decide if they're ready to move to curbs. So you can take the same approach. Is if you're ready to take the incrementalist approach, it's still pragmatic, it still works, and it'll still get you the facility that improves the current condition. So excellent point, Cheryl. So what I'd like to talk about now is I want to talk about the shared use path, because these are facilities that people love the most. They are the most idyllic, the most nature friendly. We love to get out and bike, but they don't fit everywhere, which is why we have an on-street design guidance to make sure you can try and replicate as much of that as possible in an urban environment or a suburban environment. But in a lot of cases, you'll still have a need for shared use paths. So per AASHTO, BDE, local roads, everybody kind of agrees you want 10 feet minimum, 12 feet is better. Sometimes if you have significant physical constraints, you can go down to 8 because a narrow segment is better than nothing. But you do want to make sure that you put signage and warnings about that condition. And then you can stripe your shoulders and your edge lines if you have high ADT. I would say don't bother with your center line. It's kind of assumed how it operates, but some agencies still want to do a center line, or maybe you do your center line approaching a bridge, just to kind of organize everybody a little bit, and that'll save you a little bit here and there. So this minimum width is based on where AASHTO says you need at least 10 feet, and then you need 2 feet of clear on either side before obstructions, signs, tree branches, or steep grades. So you can kind of see what your graded area needs to be. 1 to 6 is the max. And I recommend use that 1 to 6. And I actually got comments on some concept geometry this morning before today's presentation from one of our subconsultants who does a great QC on our work. It said, use the max on the side slopes, especially if you're doing this and you don't want to take right of way. That can be graded, that can be clear zone, but doesn't necessarily need to taper off really gently and you have this big right of way taking. So this gives you an idea of what your operating space needs to be. And as I mentioned at the beginning of the presentation, sometimes you'll see the word side path uttered. And this is because a side path is a shared use path within 5 feet of the face of curb or a railroad or a waterway edge. And this is different because what you do at intersections will be different than a trail that's off in the middle of a forest preserve, for example. So AASHTO and IDOT recommend that 5 foot minimum from separation of traffic. The comment I got was it should be face of curb, not back of curb. So you get a little bit of wiggle room on where it goes, but you may also need to make that space wider if you're adjacent to a railroad. They get to call the shots on how much space they say they want, or steep grades. And then AASHTO even has kind of guidings on what your railing needs to be based on what slope you're adjacent to and how far down the run you're needing to go. So I touch on it high level here, but generally this is what your envelope of space should be. So I touch on that very quickly because what I want to get to is the intersections and these types of treatments that you do when you're doing a crossing. So there are a lot, and I want to get into each of these, and we've got about 40 minutes. So hopefully we can give you some good guidance on most of these. I'd say the least of which is the roundabout. I kind of went lighter on that one because we don't have as many in Decatur. But if you have questions, you're certainly welcome to ask them. So first facility, I still consider this what I call a bike lane drop, which is not great, but it's better than nothing, is if you have an urban environment with turn lanes, you can make that a shared right turn lane and a bike lane. You can do this by placing a shared lane marking or this only accept bike sign in the roadway. And this places the bike lane within a right turn lane and doesn't require that you kind of move over to the left or hug the curb because you don't want bicyclists doing that. And this will keep a bicyclist aligned in an urban environment to go through an intersection if that lane doesn't result in a lane drop, for example. So here in this Chicago example, the roadway continues because it's on-street parking on the other side of the intersection. There's no reason to make the bicyclist move over, especially if you don't want people turning. You want to create this condition where you move the bicyclist to the left. Sometimes you'll impose a no turn on red so that the car is not honking at a bicyclist while stopped at the intersection. This is kind of your first attempt to give them some facility guidance, even if you're not giving them their own facility. And this helps to mitigate those conflicts, because if you've ever been in an intersection and a motorist tries to turn in front of you, it's known as a right hook crash, and you don't want to create a condition where that would happen. Here's a couple of examples on how you make that just a little bit better than making it a shared right turn lane. Is you can put a shared lane marking in a turn lane, place that shared lane marking where you want the bicyclist to position themselves so that they can get out of that conflict situation. So they'll be kind of to the left of the motorist who's trying to turn right. 55th Street example down on the lower left, that's a slightly more complex approach because what we have is a protected bike lane meeting a shared lane facility. So you see the bike lane symbol, then it gives way to a shared lane symbol, and then it gives way to a right turn arrow, spacing accordingly based on the posted speed and the approach to that right turn lane. And then the image on the right is just the use of a sharrow in a Montana city. Now, this is kind of a better top-down view of that 55th Street example that I show, where you have a bike lane at the curb and then a right turn lane that appears where motorists are entering into the shared lane condition. They're the ones making the lateral shift, and therefore they're the ones who are expected to yield upon entry to this shared facility. So in this situation, use the bicycle symbol to identify the intended position in there, and then the shared lane symbol in the shared environment. That turn lane needs to be between 9 and 13. IDOT requires that it should be greater than 10 or equal to or greater than 10. And then the optional treatments in this situation is you can do the dashed line upon entry, the shared lane marking, and then a right turn only regulatory sign if you feel it necessary. But if you have a little bit more space approaching an intersection and you're not doing a lane drop, it's better to actually do a through bike lane. So this can be done with or without green, but this is important where the bicyclist isn't expected to make a lateral shift. They're going straight on through an intersection. They're able to hold their line in alignment, which keeps them more visible to motorists that are attempting to enter into the turn lane. And this channelizes those movements so that the motorist crosses over when there's space to do so before beginning to make a turn. So it's not a turning crash. Side swipes in lower speed environments are prone to be less severe and less frequent. So if you're creating a condition, you're attempting to mitigate that risk by how you're designing this approach. So this is a situation where you can reduce that right hook conflict, clarify who's supposed to yield to whom, because again, the motorist is the only one that's making a shift. And so you're required to put in your edge line, your bike lane symbol. The optional treatments are your skip dash treatment. I recommend the right lane must turn right sign because that shows the beginning of the yield condition. And then the R44 shows the beginning of the shared crossover condition, begin right turn lane yield to bikes. So again, your regulatory signage can accompany your pavement markings. I think that does a great job of making it very clear to the motorist that they are supposed to yield upon entry. And then, as I mentioned before, your green pavement is optional to show this conflict zone.
Can I just mention one thing?
Yeah, Cheryl, go ahead.
Per the MUTCD, I just want to make sure everyone is aware that a bike lane must be to the left of a right turn bay. Like a bike lane, if it's through, it should never be on the right side of a right turn lane. So I forget what section of the MUTCD that is, but just want to make sure everybody was aware of that.
Yeah, that's an excellent point, Cheryl. And that actually is something that we're dealing with by trying to install a protected bike lane on the left side of a one-way street, because we are either deciding to do a shared through left or signal separation. And we're actually choosing signal separation because it's just so much more robust and easily understood so that we're not in conflict with the MUTCD. Now, if you don't have that ability, or you've got a little bit more room because of your on-street parking, you do have the ability to do what's known as a bend in. So this is where the bike lane bends in toward the travel lane, like the example Katie was asking about earlier, where you want to bring the bicyclist back into the sight line of the motorist and they're parallel to one another before a turn begins. And this brings everybody back together, kind of a shared lane environment. You see the use of this turning vehicles you yield to bike sign. And this will work in an example where you don't have a right turn lane, because as Cheryl mentioned, you cannot have a bike lane to the right of a right turn lane. You need to move them over. So this is a shared lane environment where motorists must yield, and there's a chance that there will be a motorist behind them that's wanting to go through. So not the best treatment, but it does work if you don't have a lot of turning volumes. Or let's say that this is a T intersection and there's no turns at all. This would be a good treatment to use. A bend out is where we do kind of the opposite, where we actually bend the bike lane away from the travel lane. And this might actually work because we've got a shared through and right, but now what we've done is we've actually kind of created a physical separation again, kind of like a separated bike lane. And if you look to see where the motorist that's making a turn is located and how much space we've created, that width can vary based on guidance, is you've created a space where the motorist has begun their turn. They have exited the travel lane, but they haven't yet crossed the bike lane. So you've kind of created a pocket of storage that allows them to yield a second time without fear of a rear end or a turning crash, but also allows them to yield so that you don't have a turning bike crash at the crossing. So this separates the automobile's turning movement from the bike crossing movement and allows independent yielding activity through the use of geometry. This works well. Again, it's not an exclusive right turn lane, but it does work in urban environments where you want to give that space. but also ensure that motorists have the space and the visibility to effectively yield at this crossing. Sounded like there was a comment there for a second, Cheryl.
You turned to a screen that I was going to ask you about pros and cons for bend in versus out, which is the industry trending towards.
Okay, so they're still being used. So the pros and cons, the bend in takes up less space and doesn't involve any kind of a curb. So in the example I showed in Evanston, or the one that Katie asked about, if those volumes are low and the speeds are low, the bend in actually works pretty well in that environment. You know, you may need to pull out a parking space or two for sight lines, but it's not that as robust as we were talking about. So it's lower cost, but it's less robust. I'd say that's less common, but still certainly acceptable in some conditions. Whereas the bend out does what I mentioned before. It allows the motorist to get out of the travel lane before interacting with the bicyclist, and which you'll see in a moment can also facilitate a two-stage turn for a bicyclist, which I'll get to in a moment. And if you do this with curb work, like I showed on this slide, that curb could be a refuge island for pedestrians. It can also function as a transit boarding island so that people getting on and off a bus wait on the platform and only cross the bike lane before getting on the bus, not the bike lane and the travel lane. So this can be done in that situation, which has been used in the Evanston example. But the cons for a bend out is it does take more space, does require the use of a curb more often than not. And then if you're going to do that bend out, don't put a whole bunch of stuff on that refuge that makes sightlines a problem. So be careful to do that. So I mentioned a two-stage turn. I'm not quite there in my slide presentation, but I want to touch on something first to explain why I don't use this all that often. Is early in guidance, we started to learn about the concept of a bike box, where it's actually just a setback stop bar or an advanced stop bar, where we put some pavement markings in it to say, well, this will be a great place for bicyclists to queue when they're approaching an intersection that's almost always going to have a red light when they're approaching it because the cross street is so much busier. These were originally kind of used in like environments where there was a left turn need, but not necessarily any other guidance. So if you're approaching a bike box on a red light, you can come to the stop bar, get up in front of motorists, and then go on the green and you're up front. You can get into the lane more quickly. But if you're approaching it on a green light, you can't do that because there's a chance that you're going to be trying to move laterally to the left and you're going to create a conflict that you don't want yourself to be part of. So this doesn't really facilitate left turns. So if you're seeing bike boxes or you're discussing them, don't do them when you want to facilitate a left turn. And even as I say that, I'm going to introduce a condition where a bike box might actually work, but not in the way that you might think. So bike boxes are a tool that can allow for queuing at red lights, that allows a leading bike interval or a leading pedestrian interval to let a group of bicyclists get going before the motorist. But if you're not doing it for that purpose, stay tuned because you might see it used for something slightly different. And the reason I say that is because facilitating left turns at busy intersections is stressful. So if you are on a street like this, where you've got a multi-lane roadway and the bike lane is on the right side and they want to turn left, effectively you'd have to follow this purple path, which is super stressful. I've done it in Lansing, Michigan. I do not recommend it. But what bicyclists who are defensive or interested but concerned want to do, they're like, well, let me just stay on the right and let me cross the street and just kind of hang out on the intersection in front of the stop bar for the red light because no one can turn. I don't want to be making a left turn movement, but I do need to make a left. So I'm going to follow the green pathway, go to station 1, wait for the lights to change and go to station 2. And so the two-stage turn box actually came about because we wanted to legitimize this defensive movement. So a green pavement marking, known as the two-stage turn box, can be placed at the far side of an intersection, and you kind of go around the outside of the intersection to make your left turn rather than the inside. So here's another example that shows bicyclists moving from station 1, getting out of the bike lane, but adjacent to it, hanging out in station 2, and then when the light changes, they can advance to station 3. So this splits your left turn into 2 movements. You kind of approach the intersection on the green, go to the far side, wait for the light to change, and then go. So it's done in 2 stages, which is how it got its name. And you'll see that this green pavement marking kind of hangs out in the intersection, and it does so in an area that's not in conflict with any through movement on the bike lane or cross movement on the travel lane because that cross movement has a red light. So MUTCD, this is an interim approval design treatment. Its guidance is still evolving. But the guidance does a really good job to say, if you're going to do these, you can shadow the parking lane or the travel lane on the cross street, but you are required to impose a no turn on red requirement to make sure that you don't have that turning conflict to mitigate those movements. But this does a great job of, like I said, legitimizing that defensive movement, because a bicyclist wants to make a kind of turn like this, but they want to get out of that conflict zone. So this is the two-stage turn box, and then I want to bring the bend out back into the intersection, because making that movement by going to the far side is something that bicyclists want to do to avoid conflict. And if you put them all through an intersection, you actually get what's known as the protected intersection. The image on the upper right is actually a sketch image from an older draft version of the bike guide. This could have been introduced literally 40 years ago, but the vehicular cycling movement said, we don't want to do that. We don't want to do protected intersections. We want bikes on the street, so we're not going to do this. So many years have elapsed, and we actually looked back at it and said, no, we should revisit that. So the protected intersection kind of takes that defensive movement, channelized path, and imposes geometry upon it to really bring it to that level. So turning movements are mitigated, everybody gets their own facility, and it's designed in such a way that those crossings are very visible, easy, and they're the shortest distance that they need to be for all user groups. This is that example that I was talking about earlier, where even protecting part of your intersection can make a big difference. So this is Michigan Avenue in downtown Chicago at Millennium Park approaching Randolph Street. And that northbound to right turn movement, which a lot of bicyclists like to make because it goes to the lakefront trail, was constantly being bombarded by cars also wanting to cut that corner and basically just swooping into the bike lane to make that turn. So the city kind of took a look at this for an extended period and said, let me just stripe out what should be happening. Let me add a flex post or two, and let me prevent that from happening. Suddenly, the stress level for this intersection went way down for me. I now can bike up approaching it without feeling I'm going to be cut off by an Uber or a taxi or a passenger vehicle. And it didn't take a lot to do so. And then just want to point out the one custom regulatory sign that they put at the intersection with the turn only lane and a bike turn only lane. Because this is a condition where there is no facility to move through for bicycling. And if you were that road warrior that wanted to continue north on Michigan Avenue, you would be to the left of the motorist at this point, and you would not be in the bike lane. Because most people are wanting to turn right. Now, if you do want to go through an intersection and you want to give that guidance, you can also add markings through an intersection, especially when you want the motorist, the bicyclist, and all roadway users to hold their path across the intersection. Or, for example, maybe you do have an unfortunate jog in your network and you can't avoid it. So you can clarify and anchor these pathways. And I'm going to show you a couple of examples where that's done. They can be done with or without the use of green. As you probably notice in these slides, green kind of echoes where your white dashes are. And that's generally the best practice to make sure that everything's lining up and is as visible as possible. But here's a couple of examples that were a little bit hairier that have been done over the years. Epstein did the design on the left, and the city of Chicago did their own design on the right, where we've got a six-way intersection. Everybody didn't know what was going on there, or you've got a jog. So these plans are kind of those in-progress construction documents that show you a lot more guidance on what to do with your pavement markings if you truly want to give that clarity through an intersection. And these are almost always custom, but as you'll see with the tons of callouts here on the screen, showing your width, your spacing, where it's located, what even your radius and your effective widths are. We dimension everything sometimes when we're still figuring out as we go, just so that the reviewer, the city, the client can see kind of how this would get constructed. Now, if you don't want to do it with just pavement markings, or as we've alluded to on several occasions, you're placing your bike lane to the right of a exclusive turn lane, you can use bike signals. And actually, the interim guidance on bike signals requires that if you do have this condition where you've got a bike lane adjacent to an exclusive turn lane, you do need to separate those movements through the use of a signal. So this is a condition where you have to do so. And this attachment and this exhibit kind of shows how the signal phasing and the signal head appears, which is basically its own signal head just for bikes. It's the same red, green, yellow, but we've got the bike symbol in lieu of it. And these generally are smaller or mounted a little bit lower on the near side to make sure that it's easy to see for bicycling. I used to have a bunch of other examples in my presentation, but in the interest of time, wanted to introduce it as a concept. And we can always get into examples if that does come to mind. Now, if you have a traditional signal and you want to make sure that bikes can use it and they're just going with traffic, there may be still a need to allow that bike to be detected by the signal if you're using actuated signals. Urban environments increasingly are moving to visual detection and or pre-timed, but if you still don't have that in your network and you want detection, AASHTO gives guidance for how you can change your detector loops, where you place them in the pavement, and whether or not you want to put a pavement marking over the top of it just to give that additional accommodation. I will admit that I haven't seen one of these added to any new projects in a while, but they still are out there. And here's the guidance that you would undertake to use them. So I just wanted to kind of introduce that and see if there was any questions that come up at the end of the discussion. So keep that in mind, but we can always come back to that if you have an interest.
Can I add one thing before you move on to beacons?
Sure.
Is if you have like a really heavily traveled road that is really a bikeway, you should really consider your yellow and red timings at the signal as well, to accommodate bicyclist speed, not just vehicle speed. So just consider your signal timings as well when you're installing those.
Yeah, that's a really good question, Cheryl. And then I didn't mention it, but I'll bring it up since you added it to the conversation, is if you have your bike facility adjacent to your sidewalk and your pedestrian crosswalk, more often than not, your ped clearance time is going to dictate what happens at that intersection anyway. But Cheryl's correct that if you don't have that happening and you've got a bike facility where there is no ped movement, make sure your clearance time is adequate for the speed at which you expect a bicyclist to be traveling. Now on to beacons. We're actually close to the end. Beacons and other crossing support are great because these are situations where we're not actually talking about intersections. And I like to be very clear that a beacon is a traffic control device that's different than a signal, because when a beacon is dark, we treat it very differently than if a signal has gone dark. And that's specific to not just Illinois, but a lot of state DOTs need to make that distinction so that these things can be implemented in a uniform manner. And TRA 23 IDOT guidance that came out last year provides good guidance for the use of beacons and crossing support on multi-lane mid-block crossings, whether they're signalized or unsignalized, unsignalized mid-block movements. I haven't added that to my presentation just yet, but I do need to kind of make a mention that IDOT's done a really good job of adding that to really clarify how this guidance is interpreted. So if you have a mid-block crossing, and if you have determined a need for beacons based on a traffic study or a volume analysis, consider there's two options out there. There's the rectangular rapid flash beacon, RRFB, and the high intensity activated crosswalk, also known as a HAWK. It used to be called a HAWK signal, but again, to avoid confusion, it's a beacon. Don't call it a signal, otherwise you'll get lost down a rabbit hole of terminology. They are pedestrian actuated and often will complement other treatments. And as I mentioned, IDOT's TRA 23 guidance for the use of these types of treatments at unsignalized crossings comes in handy for how to go about that. And that other crossing support that I'm mentioning is signage, obviously. So the use of regulatory signs, your yields and your stops. There are modified smaller versions specifically for bike movements. And then there's a lot of yellow warning signage that also identifies these. I call these the W series. The image on the far right, which is the bike ped trail crossing with an arrow pointing at the crossing itself, is quickly becoming the most common assembly that we like to see at trail crossings. And then you'll see another one where the arrow has been replaced with a distance to the crossing, 500 feet in advance of, so that motorists are given that guidance approaching a crossing so that they know that a mid-block crossing is coming. In addition to the regulatory signage and possibly the use of beacons and pavement markings, the angle at which a crossing occurs can also help and work in your favor if you think about how to use it. So as you're approaching a crossing, let's say we've got a rails to trails project that's crossing a roadway, chances are it would have done so at a skew, like you see here on the image showing what the alignment is suggesting. But what's actually happening is the path is being curved. And so you look to AASHTO and say, well, what is my curve radius allowed to be based on the speed at which I'm approaching the intersection? You can make these rather slow. In fact, you might want to make them slow so that when the bicyclist reaches that roadway crossing, they're more inclined to press the push button to get the beacon to activate. They're more likely to look for a gap in traffic, and they're more likely to approach it so that everyone can see each other without darting across from someone's blind spot over their left shoulder. So again, you might want to provide this in a condition where you are supplementing all of your other treatments with the use of this type of geometry. And this is a geometric design, so there's not an MUTCD situation, but it accompanies everything else like I mentioned. Now, I talked about this way back in the traffic calming for Bike Boulevard, but one of the things that you can impose on your network if you want to add your bike boulevards, and this is an intersection treatment per se, which is why it appears here, is this intersection mini traffic circle. So these things are small. You can see that this curve is pretty low. It's got a minimum 15. I said 11 earlier. I meant to say 15 curved circle width. And it's recommended in low speed, low volume environments. Most of the city's neighborhood streets have been just universally reduced to 25 miles an hour. I've got these traffic circles outside my window, and they're enhanced with the occasional shared lane marking, a neighborhood greenway designation. And these do a great job of imposing nothing else on your network other than making sure people are not blowing stop signs and cutting corners and speeding through your neighborhood greenway, but in fact is something that is more comfortable for bicycling. And then the last item that I have is the use of the roundabout. Again, we don't see a lot of these, at least in the Decatur example, but you have seen them used elsewhere. And there's two options for a bike facility that is entering a roundabout. The first option is you can do a bike lane drop and encourage the bicyclist to circulate the roundabout with traffic, especially if your speeds and your volumes are low. There's no reason you wouldn't be able to, as long as you're comfortable that everybody's entering at that same speed and volume. If that's not enough, or you want to provide an option in addition to it, you can provide a slip ramp up onto the sidewalk, widen that sidewalk to 8 to 10 feet around the outside of the side or roundabout, and then use the shared lane yield to bike sign, provide the ability for them to get back into the bike lane after they've completed their movement. And you've given them an option in either way, either on street or as a side path sidewalk solution. So that's kind of the flexibility we offer from the roundabout. And I was lying when I said we were done, because there is a median refuge island guidance in here. And this is another enhancement. TRA 23 points to this, as well as other guidance, that if you want to split your crossing into two smaller movements for a pedestrian, so they only need to look at a gap in one direction of traffic at a time. This also provides you with just a little bit of refuge, hence the name, where you've imposed a barrier curb. I really recommend a curb, not just paint, providing that space needs to be at least 6 feet wide. And as I mentioned, TRA guidance gives you a recommendation based on the number of lanes, the posted speed, and the average daily traffic on whether or not you need to add a median refuge and a beacon, or if a median refuge plus signage is enough. But these do a good job of helping to calm traffic, visually narrow the roadway, split the crossing into more than one group, and generally just improve conditions at these locations for you if you're trying to improve a crossing. So with that, we have reached our end of the content presentation. We had a lot of good Q&A from Katie and from Cheryl in there. I just want to stop here and thank everybody for a minute and reiterate, today's presentation is being recorded so that you'll have access to it afterward, as well as on demand for those who could not make it. Professional development hours are available for you if you are an engineer or a certified planner. I've put my contact information up on here if you have a bike facility design specific question. And I also wanted to use the balance of our time today to see if there's any other questions or examples or things that the group wanted to discuss. So I'm going to stop my screen share for the moment and ask if you want to come up onto chat or unmute, or feel free to come on cam and discuss. And while we wait for people to do that, Cheryl, do you have any kind of closing thoughts or comments that you wanted to discuss?
No, here we go. Sorry, not really. Just thank you everybody for attending. If you did want to learn more about our project, and what we're doing specifically for Decatur, I had put that link up at the beginning of the chat, but basically that's oh gosh, what is it? bikedecaturil.com, and that can take you to our website for this project. If you want to fill out a survey, as well as the network, if you have interest there. Otherwise, if you do have, or if you're wanting PDHs or APA CMs, we'll need you to fill out an evaluation form in order to do that. Actually, if you wanted to fill out the evaluation anyways, we would love to hear from you as to how we did today. So I just put that link in the chat as well. But I just wanted to say thank you, everybody, for attending. And I really hope that you have some questions here in the last 10 minutes here before we end. So.
Yeah, and the one reason we like to do this at this stage in the planning process is eventually a draft network will be released for review. And it will consist of shared roadway environments, visual separation, physical separation. And then we also gave you kind of a heads up as to what are you going to do as those approach an intersection and how these things get designed so that the first task after adoption is implementation. And you'll be chipping away at these, one project at a time, figuring out what's the best way to make these fit in your roadway and environment. And so there will be a lot of conversations that continue to happen. So everybody attending today has at least been given an introduction into what are these facilities called, how are they designed, how wide do they need to be, and how do you make them fit within your network based on roadway context, posted speed, user comfort, and all things like that. So again, we've been posting a lot of links in the chat, and I'm going to save a transcript to accompany this so that you have access to all of those hyperlinks, so you don't need to take those notes yourself. There's a lot of good guidance in there. And that's why I also asked everybody to put their name and title so that if you wanted to reach out to someone and say, I had a question about that, or are you going to be involved in this moving forward? There's a lot of folks who are going to be associated with the implementation. So I'm glad you all got to meet each other if you didn't know each other already. So again, thank you. Thanks to Cheryl and Katie for helping run interference on this. And thanks for Greg for helping get us up and running and organizing this. And like Cheryl said, I want to turn it over to you for the last 7 or 8 minutes to see if there's any other questions or general comments. We do have some folks from our core team who also joined us today. So again, thanks to all of you. So if anybody has a comment or question, I'm going to stop talking here for a moment and let you come off mute or enter something into the chat.
Hey, Tim, this is Greg Crow. I want to thank you and Cheryl for putting this together. This was a great overview of everything for me as a planner, not just for the Decatur Bike Plan, but something specific for Decatur for the project we're working on. You talked quite a bit about converting vehicular lanes into the use for bike lanes, and we've talked quite a bit about that with Decatur in particular, because we have probably an overbuilt street system, have potential for reducing lane widths or getting rid of some lanes that could possibly be used for bike lanes. A lot of those roads are state routes, and you showed a lot of different options on physical barriers, visual barriers. In your experience, what is the preference for IDOT?
Sure, that's a good question. And I'll talk a little bit on scope too, because some of the examples that I shared, and actually in the two-way bike facility header slide, I introduced a facility that's actually IDOT jurisdiction. So Clybourne Avenue in the city of Chicago is an arterial under IDOT jurisdiction. And it was the first protected facility that District 1 had ever attempted. And they worked with CDOT to do that. So that was another situation where the capacity was much lower than the roadway suggested. So we had an extra lane in each direction that they didn't need. So the city paid to do the work to actually go through the capacity analysis to prove that the level of service would not be terrible after the conversion. And once they reached concurrence on that, they decided that the preferred approach on that one, based on the posted speed, the number of driveway crossings, and the desired level of protection that they wanted to give to bicyclists, was physical separation. And that was a great opportunity for them to try out how to design it, how it would work. And now they like to point to that as a great example of success story by the city and the state working together to implement that project. And I constantly look to that as a design guide, as a case study for how to go about it. And generally what I have found is routes that are under the jurisdiction of the state, especially outside of major cities, tend to be higher speed, higher volume, where that desired level of physical separation is really present. So unofficially, I will say that I would not speak for IDOT, but I would say that it tends to be more desirable to do physical separation on those facilities based on its context. And if you can prove that the capacity will work, you can get a great high quality facility in there. And we have precedent that the state has an example of that in a couple of different environments. And there was one thing that came to mind that I wanted to say about that. Oh, so Greg, your comment on being a planner. I've been in the industry for about 15 years and I'm raised as a planner, and I get mistaken for an engineer when it suits my needs because of the work I do on the design side. So being able to work on projects from the plan level and then get into the conceptual design and then even into detailed design, it's been a great help. And so one of the things that we really enjoy is that the planning and engineering professions are starting to combine a little bit better. I used to cringe at the word plan engineer, but now I'm starting to see its value. So for all of you today who joined as planners, please also feel comfortable engaging in these design discussions, because I think they do come up in the planning level. And if you're able to kind of speak with the same vocabulary early on, it results in a really great conversation and it can help improve your odds during the implementation phase. So don't hesitate. You're not an imposter. You're just very enthusiastic.
Tim, this is Katie. I had another question. For somebody who is interested in learning more, where can people go for more training or information about these topics?
So I would say that the starting point would definitely be to actually visit the NACTO and FHWA websites. They provide a lot of good case studies, and the FHWA Small Town and Rural Multimodal Networks Guide also provided in their free PDF the name of the individual who provided the case study. So if they still work for that city or that DOT, you might even be able to track that person down and learn their specific experience for how they encountered or conquered something. And then NACTO does a great job of putting together videos and other types of things like that. And NACTO also has its own roster of trainers. As Cheryl mentioned at the beginning, I'm NACTO certified. Just like any other consultant, we would then bid to give a NACTO training, but they're usually organized by NACTO and for a specific client. So, occasionally I will receive an email saying, we need proposals from certified trainers that are interested in giving a training in Lincoln, Nebraska. So if you have any connection to Lincoln or any familiarity, please respond with your proposal, and those can be set up. And those give in-depth day-long or 2-day-long design trainings. When I do them and when a lot of trainers do them, they actually encourage participants to bring homework with them to the class, saying, if you have a design challenge or if you have a project you're working on and you want to go through it with a table full of 10, 12 people, bring that to the class and we'll hash it out. So as I mentioned, the learn by example or the learn by doing is kind of a method that I find really works for me. And then obviously by visiting those agencies, following them on their newsletters, you get to learn about the newest and greatest best practices coming out of it. IDOT has its own training. National Highway Institute has its own training. So this stuff is evolving at such a rapid pace that I think that, even as I'm giving this, I learn at the end of the day today, I need to add the TRA 23 guidance slides to this presentation because we just learned about that. And that guidance was great help on some of the projects I've been doing. So a lot of resources out there. And the good news is most of them are free. And if you're interested in a deep dive, you can always reach out and inquire further.
Along those lines, as you just mentioned, it's been a very fast and furious changes over the past 10, 15, even 20 years, in guidance. So, how would you recommend that Decatur move forward? Well, I mentioned Decatur just because, that's for our project here, but, the tried and true versus too experimental versus, how can they be sure that what they're investing in, is going to be the best practice for, the near future here or long-term future?
Yeah, that's a good question. And I've got a few points that I want to touch on. The first is that the MUTCD is due for an update, and the AASHTO Bike Guide is coming out with its 5th edition very soon. Both of those are going to further clarify the guidance that's been evolving. And the practice, which I didn't have a slide on it today, but on my longer recordings, I do, where the MUTCD will receive requests to experiment. There's a formalized process section 1A10 to be specific, where you can request to experiment on a treatment that you find would be worthwhile for your experience in your city. And you document the reasons why you want to do it. And they request that you collect data before, during, and after its installation. And we learn from that, from people around the city, just like Decatur. How is this working? What problem are we trying to solve? And when it goes from experimental and we learn enough about it, then it moves into that interim approval stage, which implies that we're going to continue to evolve its guidance. And then you more likely than not will see it as an accepted practice in the next edition. So when something is subject to interim approval, that's FHWA signaling that they're pretty ready to embrace it, and you'll see it in the next edition. But since there's a long lead time between editions, they don't want you to stop innovating while they wait to publish. So that's a great example to say, if you see something experimental, if you see something that's subject to interim approval, it's definitely worth looking at because it has a really good chance of working well for your needs. And so latest and greatest is always evolving. Embrace it if it works, and be curious about where it might work in your city. So we are at the 1 o'clock hour. I definitely want to thank everybody for coming. As I mentioned again, we'll be recording it, and definitely thank you for your participation this afternoon.
Yes, and please fill out that evaluation form if you can. So thank you so much, everybody.
All right, thanks everybody.